Alright, so we're going to talk a little bit about how to solve exponential and logarithmic equations here. This I'm just going to go through some examples. The first one, we want to solve these. We'll have a part A and a part B to this. If I have 4 to the x minus 1 equals 16 to the x, if I note that 16 equals 4 to the second, then I can write this as 4 to the x minus 1 equals 4 to the second to the x, like that, which then allows me to write this as 4 to the x minus 1 equals 4 to the 2x, because when you raise powers, 2 powers, you multiply the exponents. So once you've got the bases the same like this, then you can ignore them and just solve the exponents equal to each other. So if I do this, in the quickest way is to just subtract x on both sides. I get negative 1 equals x. In part B, let's do e to the 2x minus 3 e to the x, e raised to the x power plus 2 equals 0. And I'm going to do a u substitution here. I'm going to let u equal e to the x. And what that's going to do is then I'm going to have u to the second, because e to the x squared is e to the 2x, minus 3u plus 2 equals 0. Excuse me. And I can factor that into u minus 2 times u minus 1 equals 0, giving me either u minus 2 equals 0, which gives me u equals 2, or u minus 1 equals 0, which gives me u equals 1, which means that e to the x equals 2, or e to the x equals 1. And the way you solve these are two different problems. You take the natural log on both sides, and that's how you solve these. The natural log cancels the e, so it gives you x equals the natural log of 2 is one of your answers. And then the natural log cancels the e and gives you x equals, and the natural log of 1 means e to the something equals 1, and means, I'll do that in a little box over here, e to the something equals 1. That means that the something has to be 0. So there's the two answers for that one. Let's go to a new board here. Let's do a couple more of these. If I solve, let's see, we'll have an a and a b again. 3 to the x equals 19. This one, I can take the natural log on both sides, and then I can use the property that this exponent can be moved out to the front, so I can have x times the natural log of 3 equals the natural log of 19, and then I can just divide by the natural log of 3 on both sides, and I get x equals natural log of 19 over natural log of 3, and you can put that into a calculator, and when you do, you get approximately 2.6 6/8. So that's how you would do that problem. Part B, let's do one that's a little more involved. E to the 8x plus 1. Having a hard time writing stuff right now. E to the 8x plus 1 minus 6, 6 less than that, equals 1. Let's add 6 to both sides first so that we get the e. So we get the e to the 8x plus 1 by itself. And then we'll take the natural log of both sides. And the natural log will cancel the e, and I'll have 8x plus 1 equals the natural log of 7. We'll subtract 1 on both sides, and that'll be 8x equals the natural log of 7, and then 1 less than that, and then we'll divide the whole thing by 8. And we'll have x equals natural log of 7 minus 1 all over 8. And if you put that into a calculator or into Desmos or whatever, you'll find that that is about 0.12. So there's the answers for those types of problems. Let's go to a new board. Excuse me again. And example 3. By the way, these are the same examples that we did for the notes. Okay. Let's solve 3 to the 2x equals 6 to the x minus 1. Now, there's no way I can give those the same base, so the other option is to take the natural log of both sides, move these exponents to the front, so I have 2x times the natural log of 3 equals the quantity x minus 1 times the natural log of 6. Now that's important because we're going to actually have to distribute that. So that's 2x times the natural log of 3 equals x times the natural log of 6 minus 1 times the natural log of 6, which is just the natural log of 6. So the trick here then is put all your x's on one side, all your non-x's on the other side. So I'm going to do minus x times the natural log of 6 minus x times the natural log of 6 here. And that's going to give me 2x times the natural log of 3 minus x times the natural log of 6 equals the negative natural log of 6. And notice how these both have an x in them now. That means that I can factor that x to the front. And that's going to allow me to finish the problem, because now that I have the x multiplied by this whole big thing here, I can just divide by that whole big thing on both sides. And so x equals the negative natural log of 6 over 2 times the natural log of 3 minus the natural log of 6, which you could go through a whole lot of things, but bottom line is when you put in the new calculator, you get about negative 4.42. And you can put that into Desmos in just that exact way, and it'll give you that answer. Let's do another one. And let's solve a logarithm equation here. Let's have 2 times log base 5 of 4x minus 1 equals 11. And what we're going to do is we're going to add 1 to both sides here. We'll have 2 times log base 5 of 4x equals 12. And what I'm doing is I'm getting the logarithm by itself. So now I'm going to divide by 2 on both sides and have log base 5 of 4x equals 6. And once I've done this, you can give them both a base of 5 and make them exponents, and then the log and the base will cancel each other, and you'll have 4x equals 5 to the 6th, like that, and then you can divide by 4, divide by 4, let me move it up to here, and then you have x equals 5 to the 6th divided by 4, and whatever that happens to be. One last example that we can go through here. Let's solve log base 2 of the quantity x minus 6 equals 5 minus log base 2 of 2x. And let's try and come up with something for that. Let's get all the logs on the same side. So I'll add this log base 2 of 2x over here. And I'll have log base 2 of the quantity x minus 6 plus log base 2 of 2x equals 5. Now this is only helpful if the bases are the same. So you got to be conscious of that. Now I'm adding 2 logs of the same base here, which means I can condense them into one big logarithm where I am multiplying those 2 parts, which will be a distribution for me. I can distribute to there and there. So log base 2 of 2x squared minus, oops, not 6, but 12x, 6 times 2 is 12, equals 5. And now that I've got that single log, I can give a base of 2 to both things. I'm matching the base of the logarithm. And this will cancel this, and I'll have 2x squared minus 12x equals 2 to the 5th, which just so happens to be 32. And then I can subtract 32 on both sides and have 2x squared minus 12x minus 32 equals 0. And then I've just got a quadratic to solve. Let me rewrite that on a new board, and we'll solve that. 2x squared minus 12x minus 32. 2x squared minus 12x minus 32 equals 0. And what we'll do is notice that I can factor a 2 out of everything, and that'll make the factoring a little bit easier. Let's see, that's x squared minus 6x minus 16. And if I divide everything by 2, then I have x squared minus 6x minus 16 equals 0. And it turns out that, thankfully, this factors. You'd have an x there, an x there, and 2 things that multiply to make 16 and subtract to make 6 are, well, let's see, 8 and 2, right? 8 minus 2 is 6, and 8 times 2 is 16, and the bigger one gets that, so it's minus there, plus there. One of them's plus, one of them's minus, because that is a minus. So we get 2 answers, either x minus 8 equals 0, which gives me an answer of x equals 8, or x plus 2 equals 0, which gives me an answer of x equals negative 2, and then you have to check them in the original. So in the original, let's do the checking over here. In the original, we had log base 2 of x minus 6 equals 5 minus log base 2 of 2x. But right away, if x equals negative 2, then log base 2 of x minus 6 is then negative 2 minus 6, which is log base 2 of negative 8. Now, think about what that means. That means that there's some number, or that 2 raised to some number equals negative 8. And there are no real numbers that can do that. This is not possible. So, x cannot equal negative 2 because if even one part of the original equation isn't possible to do, we have to throw it out. However, for x equals 8, we're okay, because if I put an 8 there, then I get 8 minus 6 is 2. Log base 2 of 2 is something that can happen. If I put an 8 there, I get a positive number, so that's just fine too. Basically, as long as it's log base anything of a positive number, it can't be 0, it can't be negative, but as long as it's of a positive number, you're okay. So x equals 8 winds up being my final answer. I hope you find this helpful. Thank you.